prepare yourself for an incredible space spectacle on the horizon. A vibrant pink giant star found on the border of our own galaxy is transmitting peculiar messages throughout the universe. Scientists using the James Webb Space Telescope have uncovered unsettling discoveries regarding this giant celestial object. Renowned astrophysicist Brian Cox issued a chilling warning, posing the question to us: are we on the cusp of seeing a cataclysmic supernova explosion that would forever change our night sky? We're about to get into the nitty-gritty of space's vastness, where stars are born, live, and eventually reach their ultimate demise in an inspiring spectacle. Standing as a focus and challenge for astronomers and the masses is one star that has recently captured significant attention: Betelgeuse, a dark red supergiant of humongous size and age, residing in the center of the constellation Orion. While its characteristic reddish hue and changing brightness have been a source of concern to observers for a long time, recent developments have increased interest in this stellar giant. As we look at the nature of Betelgeuse, we stand at the doorstep of an undoubtedly titanic event in the celestial life cycle. But what are these changes in Betelgeuse supposed to mean? Are we witnessing the onset of an unimaginably stupendous cosmic spectacle? Betelgeuse is approximately 764 times the size of our Sun, a giant star of colossal proportions almost beyond human comprehension. Imagine a star of such magnitude that, if it were to replace our Sun, its surface could extend past the orbit of Mars, its stellar body encompassing Mercury, Venus, Earth, and Mars. This remarkable size not only features Betelgeuse's physical characteristics but also mirrors its stage within the stellar life cycle. As a red supergiant, Betelgeuse is at the end of its life, characterized by the process of growth and cooling following a lifetime of burning hydrogen into helium in its core. Despite being remarkably young in human years, approximately 8 to 8.5 million years of age, Betelgeuse's red supergiant status is the culmination of tens of thousands of years of stellar evolution, transitioning from a hot blue star to the red giant we see today. Betelgeuse's red-hued color is based on its cooler surface temperature relative to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's less vibrant surface suggests temperatures of some 3,000 to 3,500 Kelvin, emitting light at wavelengths that give it a red color. This color is not just a surface-level trait but provides hints about the physical condition of the star, as well as the processes occurring within its enormous gaseous bulk. Adding to the mystery of Betelgeuse is its former color. Ancient Chinese and Roman writings describe it as a yellow star around 2,000 years ago, although Arabic scholars had originally described it as crimson way back in the 9th century. This coloration shift over time is full of clues regarding the evolutionary history of the star. The volatility of Betelgeuse's brightness is similarly fascinating. As a semi-regular variable star, its light occasionally grows and diminishes in a dance of brightness with a 400-day period and a more extended period of approximately 5 years. These cycles have been noted since 1836 by Sir John Herschel and perhaps even before that in Aboriginal folklore. What adds to the suspense of Betelgeuse is not only its variability in brightness but also its unpredictability. Unlike most stars that adhere to a steadfast pattern, Betelgeuse sometimes deviates from its cadence, brightening and fading unpredictably, indicating intricate and much less mundane processes in its massive body. In the latest groundbreaking breakthrough, Betelgeuse startled astronomers and celestial observers around the globe with a sudden and striking change in its appearance. Infamously dubbed the Great Dimming at the end of 2019, the red supergiant star, one of the brightest in the night sky and a well-known feature of the Orion constellation, began to dim mysteriously. The decline of the giant star was so remarkable that it started to lose its luminosity at a mean rate of 0.1 magnitudes per day, bottoming out in February 2020. Betelgeuse, usually observable to the naked eye even in urban light pollution, became quite dimmer, a challenge even amateur astronomers had to face. There may, however, be an explanation. While trying to monitor Betelgeuse's performance, the time paradox becomes evident. When we view a star like Betelgeuse, we are not seeing it as it is in the present but as it was in the past due to the time it takes for light to reach us. At approximately 725 light-years away, the light we see today left the star close to 7 centuries ago. That latency complicates predictability and reveals unexpected changes in a star's conduct because we are observing its past effectively. Andrea Dupree, co-director of Harvard's and Smithsonian's Center for Astrophysics, along with her collaborators, closely observed the unfolding star drama with the Hubble Space Telescope. They observed the giant superstar as part of a 3-month examination to trace variations in Betelgeuse's outer atmosphere. These observations provided accurate insight into the dynamics of a variable star like Betelgeuse, which regularly swells and shrinks, resulting in changes in brightness. Hubble's ultraviolet sensitivity enabled scientists to explore the layers above the star's surface, warmed partly by the star's turbulent convection cells. Further examination of Hubble spectra received at unusual points in 2019 and 2020 helped measure material movement within the outer atmosphere of Betelgeuse, specifically targeting magnesium traces in accordance with the star's atmospheric circumstances. What they discovered was material moving at 200,000 kilometers per hour from the surface of the star to outer environment. This hot, dense material subsequently expanded hundreds of thousands of miles from Betelgeuse and developed into the precursor to the dust cloud that marked the star's dimming. Dupree and her colleagues estimated that this amount of material was about twice the normal amount from Betelgeuse's southern hemisphere that became displaced during the 3 months of the outburst. This loss of mass manifested in enormous quantities, considering that Betelgeuse, like all stars, gradually loses mass, though at a rate considerably greater than our Sun. The scale of this mass loss and subsequent dimming raised a question among astronomers. Was this event the precursor to a supernova explosion? The comparative proximity of Betelgeuse, some 725 light-years from Earth, contributes to the intrigue. The nature of such an explosion would be discernible on Earth and offer a rare chance to behold a supernova up close. Yet, the question remains, what does this dimming phenomenon portend for the future of Betelgeuse? Is it a harbinger of an imminent supernova, or merely an isolated event in the star's long-lived existence? Several theories were proposed to explain this sudden change. One prominent theory suggested that Betelgeuse was entering a stage in the supernova explosion process, a concept gaining popularity due to the widespread belief that the star is nearing its demise. Another favored theory proposed that dust, likely from Betelgeuse itself, was obstructing our view. Red supergiants like Betelgeuse lose material, and it was suggested that this ejected material could have formed a dense dust cloud, leading to the dimming effect observed from Earth. A third theory questioned fluctuations in the star's photosphere, its visible surface layer, which could impact its apparent brightness. To solve this mystery, an investigation using several observational methods became necessary. Spectroscopic observation found a decrease in Betelgeuse's intense heat, which meant the dimming could be caused by a massive dark blotch on the star's surface. Supporting this idea was the discovery that Betelgeuse's temperature declined by no less than 70 Kelvin over the period of dimming, indicating very significant changes in the surface. The breakthrough in understanding this bizarre phenomenon came from the Hubble Space Telescope, the watchful eye of humanity in the vastness of space. Hubble's observations indicated that Betelgeuse's dimming was likely caused by a massive ejection of hot material into space. This material formed a cloud of dust, which obscured a portion of the star's surface, reducing the amount of light reaching us from Betelgeuse. This dust cloud was believed to have originated from superheated plasma that was expelled by a giant convection cell on the star's surface. As the plasma cooled and condensed into dust grains, it created a veil that blocked light from perhaps a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, played a crucial role in constructing a timeline for Betelgeuse's fading. By December 2019, different Earth-based telescopes observed the star's southern hemisphere growing dimmer, reinforcing the theory that outward-moving material caused this phenomenon.